We're live.
Good evening, everyone, and thank you for joining us today. This is our last panel discussion on weather and climate research and services in India under the initiative Across the Table, a series of thematic panel discussions brought to you by the Science Policy Forum in partnership with the Gooby Lab. I am Namita Pandey, and I'll be moderating this session with one of the renowned weather and climate scientists in India, Dr. Akhilesh Gupta. With wide range experience and expertise of being a leading weather forecaster, researcher, and also a mission director of two national climate change missions, Dr. Gupta is currently heading the Policy and Program Coordination Division at the Department of Science and Technology. He is also steering the STIP 2020 process as the head of the STIP 2020 Secretariat. He has been the secretary to the UGC and has published nearly 200 research papers in national and international journals. Today, Dr. Gupta will not just be doing the moderating, but he'll also be the panelist. It is an honor to moderate this panel with you, Dr. Gupta. Welcome, sir. Before I go ahead to introduce our other panelists, I would like to inform our audience that the session is live streaming on YouTube. It is requested to please put in your questions and your comments with the hashtag AskSTIP2020Climate. For today's discussion on weather and climate research and services, we have with us 5 accomplished panelists who will provide us with their perspectives and viewpoints on this theme in context to the STIP 2020. I welcome our first panelist, Professor Susheel Kumar Dash, former president of the Indian Meteorological Society and council member for WMO Region 2 in IFMS. Professor Dash has served as the head of the Center for Atmospheric Sciences at IIT Delhi and continued there as emeritus professor. His passion for climate research has kept him actively involved in various assignments related to interannual variability of Indian summer monsoon, climate modeling, regional climate change studies, and high performance computing in numerical weather models. Welcome, Professor Das. Our next panelist is Dr. M.Mohapatra, the Director General of Meteorology, Indian Meteorological Department. He is the permanent representative of India at WMO and elected as a member of Executive Council of WMO. With a PhD in physics and nearly an experience of 27 years in meteorology, he has made significant contribution in improvement of the early warning systems and services of IMD. Dr. Mohapatra has edited 3 books and 7 journals and published more than 85 research papers in national and international journals. He is a fellow of the Indian Meteorological Society and Indian Climate Congress. He is also a recipient of the Young Scientist Award for the from the Ministry of Earth Sciences. He is the elected president of Indian Meteorological Society. Welcome, Dr. Mohapatra. Our next panelist is Dr. Anamika Bharwar, who is a professor of the Department of Humanities and Social Science at IIT Guwahati. Trained in ecological economics, she has worked in the area of climate change and water security, ecological footprints, virtual water flow through trade and water governance, including transboundary water governance. Her research interest lies in understanding how political, social, and economic factors that shape environmental decision and change, particularly related to water. One of her pioneering work include developing vulnerability profiles of 29 states of India for the first time under a common framework for adaptation planning. She has published in peer-reviewed journals at different level and repute, and has recently edited a book on climate change governance and adaptation, published by the CRC Press. Welcome, Professor Barua. We have Dr. Mamta Sharma as our next panelist. She is a theme leader and principal scientist at ICRISAT. Dr. Sharma leads a team of 40 plus staff to develop cost-effective and eco-friendly disease and pest management technologies as engaged in basic, strategic, and applied research. Her current research focus on preparedness for climate change and emerging diseases in agriculture. She has published more than 100 journal articles and is a recipient of several awards, including Women Scientist of India 2018 by India Today Group. Welcome, Dr. Sharma. Last but not least, I would like to welcome our last panelist, Mr. Vinson Kurian, Senior Deputy Editor with the Hindu Business Line. He is perhaps the only person from the mainstream media who has a daily column of his own on weather and climate for over the last 20 years, which is widely followed across the nation and abroad. He has put in more than 30 years of service and is associated with leading news dailies, including the Indian Express, the Times of India, and many others. His weather column has taken him to prestigious platforms within the country and abroad. And he has delivered talks and different deliberations on weather communication on different platforms. Welcome, Mr. Kurian. May I now invite Dr. Akhilesh Gupta to talk briefly about the STIP 2020 process and set the context for today's meeting. Over to you, Dr. Gupta.
Thank you, Nimita, and very good evening to everybody. Let me join Nimita in welcoming our distinguished panelists and the viewers who are watching from India and abroad. Today I'm here, as Nimita mentioned, in fact, three different roles that I play today. One, that I'm moderator, one of the moderator with Nimita. Also, I am the panelist. But third most important role that I play today is I am part of the STIP 2020 team that is actually bringing you all these programs. We, in fact, last 15 days or so, we have been having this kind of panel discussions. We started on 24th of June, and today being the last, so this is the grand finale of the this discussion that we started on 24th June. We had, this is the 16th of discussion, but the discussion has had very successful, I would say, conclusion. We had 74 experts participating in different discussions during past 15 days. More than 5,000 people, viewers have joined from 60 countries across the world. And more than 1,000 comments have been received from them. And all these are being collated by our team and used for our, all this thing, these kind of discussion and the panel have been brought through a very dedicated team of young professionals and, I would say, a fellow of the, the team of STIP 2020. And this is, I want to show a glimpse of, what we have, these are, so you can look at this team that we have, I call them special 25 team from STIP 2020. And you will, this is amazed to see the kind of energy level, the kind of knowledge level, and the excitement that these young people are contributing to this STIP 2020 Secretariat. And the average age of this group is less than 30. and the oldest among all. So, if I exclude myself, this average will come down. And here is the team which is backing the STIP 2020 team. That is a team from the Science Policy Forum and Google Lab. They are the back-end team which are working. So this is the kind of, you can say that the team that has been bringing all these things. So I think I have, I think before I proceed, I must acknowledge with thanks the contribution that they are making. And as these young people say, I have learned this new term that let's do a big shout. And so, the STIP 2020 formulation process is a very kind of unique concept and formulation system that we have in fact devised. It is a 4-track, all interlinked with each other process. Track 2 is the process through which we have the thematic group discussion with 21 groups, more than 130 plus experts in 21 thematic group, sitting for hundreds of meetings without a very set of good recommendations. This is the process that we just completed. Track 3 is in the interministerial and the state level consultation that we have also initiated, and now in fact there is going to be advanced consultation going on. Track 4 is the effects level discussion. We already launched that in January and now going to proceed further. And track 1, which is the most exhaustive, much deeper and much extensive in its coverage, is the one that under which we had discussion today. And this is in fact under this thing we have several components of this. We are going out to the public in all possible ways to get their feedback. In fact, this is one of, I would say, this is the first time in the history of at least science and technology policy formulation system where we are going to 1,000 universities, 40,000 colleges, 2 lakh schools, and so something like we are going to cover more than 1 crore stakeholder as a part of this consultation. So this is the huge coverage that we have. This is a big challenge that we have taken, that we have to finish the entire process within next 6 months. And so with that, I think, and this is a very unique, as I said, process where it has 5 guiding principles. It is a decentralized process, it is a bottom-up, it is expert-driven, it is evidence-supported and inclusive process. And therefore, this is going to be something unique or the thing. So with that, I hand over to Nimita before we go to the next segment. Thank you.
Thank you, Dr. Gupta, for setting the context. And as say, I think you have given a big shout to one and all to contribute to the STIP 2020 process. I once again remind our audience on that note that they could participate in this discussion by sending us their questions and comments with the hashtag AskSTIP2020Climate on social medias and drop in their comments and questions in the YouTube box. Okay. With this, I invite my co-moderator. Now, I would request Dr. Gupta to wear the hat of the moderator and initiate the discussion. Over to you, Dr. Gupta.
Proceed further. So, this part of the panel basically has, in fact, there are 4 segments of the entire discussion process. I think all the 4 segments have been divided in such a way that there is a free flow of discussion. And therefore, let me start with the part A of the discussion, where I'm going to ask. This is a kind of warming up session where we are going to ask questions to the panelists in their area of interest as to what is the status and the way forward. So basically, they are, and then I will come to the next part where I'm going to ask some pre-curated questions. And then there will be third part where Nimita will ask question coming from the floor. And then we'll have a concluding session. So this is the fourth part. Let me start the first part. So, I think let me set the context of the discussion. India has made considerable progress in the recent time in the area of weather and climate. It's all in the area of weather observation, both conventional and non-conventional, predictions of all ranges, warning system, dissemination system, weather and climate modeling system, and so on. And therefore, and the all kudos to the agencies like India Meteorological Department who have led this kind of development and the advances. So now, in fact, the weather and climate in fact are impacting everybody is impacted. And as economy grows and as the society grows, the importance of weather and climate is going to grow further. And therefore, it is very important to have this discussion today where, we talk about the how and what take stock of where we are and how we can go forward. One of the very important, in fact, area that we had to focus is the challenges that weather forecasters are going to have because of the increase in the extreme events, be it storms or the heavy rain or heat wave or such thing. And so there are going to be greater challenges to the weather forecaster in the time to come. In fact, also that although we have been able to reduce the the number of deaths, but the cost of weather extremes is actually rising because of the higher infrastructural facilities that we have. So cost of disaster, in fact, we have latest data which showing that across the world, globally, roughly $300 billion is lost because of the natural disaster every year. And so is the case in India. Roughly $10 billion, which comes to close to 2% of the GDP, is lost every year. And therefore, the role of disaster managers and the weather forecaster are very important. If we can save 10% of the loss that we incur because of this thing, I think it's a great service to the nation. And therefore, the services and backed by the research become very, very important. And therefore, we must have, a very kind of, update on what progress is in. Similarly, climate change is in fact already impacting India in a very bad way, and we need to have adaptation and mitigation strategy addressing such kind of impact and challenges arising out of things. Climate services, in fact, is a new kind of responsibility that World Meteorological Organization, as a part of GSCS, has been focused on all meteorological services in the world, and so is the case in the India Meteorological Department. And I think this is the service in offering, and they already, I think, a lot of work has already been done, and so we'll discuss on this issue as well. Also, as a part of the research initiative on climate, so much initiative have come from various ministries. India Meteorological Department has a research, the Ministry of Earth Sciences has a climate research center in IITM, and in DST also has set up a large number of center of excellence and network program and major R&D program, and also the task forces as a part of the Himalayan mission. So there's so much is taking place in terms of research network also in the country. All these we will discuss in I said in a nutshell, but I think we need to have discussion with the panelists. So I think with this, let me once again welcome our panelists, and let me start my first question with Dr. M.Mohapatra, the Director General of IMD. And may I mean, start with a question to you that you have been a champion of weather forecasting in the country, both in the personal capacity, also in your present position as Director General. And the India Meteorological Department is then has been the national weather service in the country. Uh, uh, in your opinion, what do you think that how has been the progress in India in terms of weather forecasting and in totality weather services in recent time, and what do you think where India stand in terms of these services globally, and what are your plans to improve upon and also make it much more, I would say, important in the future? So your future plan for weather services. So over to Dr. Mohapatra.
Thank you, Dr. Gupta, for giving me this opportunity to participate in this August forum. As you have pointed out, there has been a paradigm shift in the approach of weather and climate services in the country. It has been possible, especially in recent years, last 10 years, if you just look at, there has been tremendous improvement in all the components of weather and climate services, especially with respect to observations, analysis, modeling, and services, forecasting, early warning, etc. And it has been possible because of the substantial contribution towards capacity building in terms of research and development and training of the human resources and the augmentation of our infrastructure, especially the observational infrastructure and modeling infrastructure. If I just go back, Ministry of Earth Sciences decided to have the modernization program of the various components, and as a result, it brought forward all the components of Earth system sciences with its establishment in 2006. Accordingly, in 2009, Ministry initiated a process of Vision 2020 with respect to weather forecasting services. If I just mention here, where I was a co-author for chapters on Vision 2020, it was expected that weather forecasting and warning services will improve by about 20% in terms of accuracy and service delivery by 2015 and by 40% by 2020. But if you compare now the realized status in 2020 with the vision document that was prepared in 2010, you will find that in many of the fields, we have exceeded the limit fixed by 2010. If you compare the forecasting services and warning services to the severe weather events like tropical cyclones, India is second to none in the world. Its forecasting and early warning services with the significant lead period of about 5 to 7 days has helped the disaster managers to minimize the loss of lives and properties. Similarly, if you just look at the heavy rainfall which leads to floods during monsoon season, it has improved by more than 50% during this 10 years period. For the first time in the country, we have come up with the warning of the lightning. We have introduced all ranges of forecasting, starting with nowcasting to 3 hours to seasonal forecasting for month or a season as a whole. In 2015, operationally, we introduced the extended range forecast valid for next 2 weeks, and which is quite useful for various sectors in terms of management of weather and its applications. Not only in terms of weather forecasting, India Meteorological Department and Ministry of Earth Sciences also introduced the new services and augmented the existing services. As you know, the most important service which India Meteorological Department provides in the country is the forecast or agriculture sector. It has taken a quantum jump in recent years in terms of reaching out to about 42 million people, farmers in the country. At the same time, we have been more specific with a joint development of the agro-meteorological services for the farmers and the disaster managers for the major crops of the country. Similarly, with respect to the other sectors of socio-economic activity, we have introduced the new services for navigation, tourism, industry, and many other sectors. Especially when you come up with the improvement in socio-economic conditions of the country, the demand for more and more accurate forecast, demand for the more and more lead period, and demand for more specific information for different sectors has increased. Just to mention with, the demand for energy sector in terms of conventional energy and non-conventional energy has come up, and we have addressed to provide the forecast in these sectors also. Similarly, due to the increase in population in urban areas, there is a major threat to provide the real-time informations as well as the forecast for urban meteorological services. And you'll be happy to know that India Meteorological Department has also introduced the urban meteorological services. And to come up with, we have started services in 2 major cities like Chennai and Mumbai. So to summarize, I will say that there has been a significant improvement with the augmentation of various types of observations in terms of automated weather stations, automated rain gauges, deployed radars, and also it has been complemented by various types of satellites from Indian space organizations like INSAT-3D, INSAT-3DR, and SCATSAT. At the same time, we have shifted from a manual process of analysis and forecasting to an automated process of analysis and forecasting utilizing objective decisions of the system. Gone are those days when India did not have any weather forecasting models. At present, Minister of Earth Sciences runs 7 numerical weather prediction models with the help of a high-power computing system with a capacity of 10 petaflop. As a result, within 3 hours of the initial observations, we are able to provide the forecast utilizing the global models and regional models. All this has helped to provide location-specific forecast for all the cities, major cities, and also the district level high-impact weather event forecasting and early warning services. You'll be happy to know that we have shifted from the approach of what the weather will be to what the weather will do. That means we have shifted from our approach of simple weather forecasting to the impact-based forecast and risk-based warning. To begin with, we started impact-based forecast for cyclone, and gradually we have applied for heat waves, cold waves, fogs, and lightning, thunderstorms, and also the heavy rainfall. And the progress is going on, but however, as you indicated, there are still miles to go. There are increasing demands. According to the supply has to increase. There is also certain limitations with respect to scientific understanding, especially with respect to the mesoscale weather events. Though in recent period, we have come up the better understanding with help of the lightning detectors, mesoscale activities like lightning, thunderstorms have been detected with the 27 radars. But still, we have to go for augmenting our mesoscale weather events in view of especially the climate change phenomena, so that we can have the better detection, better monitoring, and better prediction with the period of these mesoscale events. I am stressing upon this because though the number of loss of lives due to cyclones and other major weather events have decreased, but number of loss of lives due to thunderstorms and lightning are still increasing. Therefore, there is a challenge to minimize the loss of lives due to these mesoscale events like thunderstorm and lightning. At the same time, as you told, the loss of our property, or you can say the impact on the property, is not decreasing, it is increasing, basically because the economic condition of the country is increasing. So therefore, the next goal is to improve the weather forecast and warning services from simple weather forecasting to dynamic impact-based weather forecast and warning services, so that we can minimize the loss of property as well. I'll stop here and we'll see the questions afterwards.
Thank you, Dr. Mohapatra. And really, I think it's really heartening that Andy has made such progress in the past. But there is, I mean, not only in terms of better observation, but also so much in the area of prediction. And as you mentioned, it is mainly because of the advancement in the modeling that we have. Also, you have done, I think, some outstanding progress in the area of customized forecast. I like your, statement that, I think IND is moving in a direction where to, not say that what will be the weather, but what will it do. So basically, you are progressing, you are moving towards the impact-based forecast, which is, I think, will be the great kind of step in that direction. And I, in fact, congratulate you and also wish you that you will be able to achieve such kind of thing. So let's now move to the next panelist. I would now ask my next question to Mr. Vinson Kurian. So, Mr. Kurian, I think I always call Kurian that, although he has never had a formal training in the meteorology, but he knows more meteorology than most of the meteorologists know. So I think I compliment you for having worked in the area of weather reporting for past two decades. I think you are the only journalist who does this kind of day-to-day reporting in the country, and you have been very, well-deserved, and you have been recognized over the world, on this kind of endeavor. So let me ask a question that, since you have been also following IND forecast very closely, I would like to ask you your opinion. And Dr. Mohapatra has mentioned that what progress has been done. What is your perspective of the challenges of weather forecasting that you see in the context of not just India as a whole, but also at the at the level of say states or even at the subdivision level, at the lower the local level delivery. And also I think we also would like to know from you what do you see from your side, your angle, are the major gaps in the forecasting or the services being rendered by the National Weather Service? Mr. Kurian.
I'm so thankful to you and Dr. Namita for having me here. And good evening, Dr. Mohapatra. We're face to face for the first time. I'm so glad that we are together in this session. Let me just recall the clarion call given by the World Meteorological Organization last year. For the need for the hour is weather ready, climate smart, and water wise. So I think we are touching upon all these three major points, which make a lot of sense in the context of the weather, which is becoming predictably unpredictable through the year. And let me start by saying, again, referring to the, as Dr. Gupta said, the global framework of climate services put out by the WMO, in which they have listed out 5 very, what they call as integrated pillars on which the framework is mounted. I think the IMD has done very well with respect to the first 3, which are observation and monitoring, climate services and information system, and research and modeling. These three, I think, I mean, the IMD is known to have done very well. But I just wanted to touch upon two basic aspects, which again form part of the 5 integrated pillars. The first one is user interface platforms, and number 2, capacity development. So I'm here speaking on behalf of the users, the end users of the weather products, solutions, and services. I'm just a writer on, I don't have any, I'm not a meteorologist, I'm not a scientist, but I've been writing on weather based on what I've been able to learn as a amateur and passionate watcher of weather. So it's not just for the IMD I'm talking about. All national forecasting agencies, I think they have come to a point where they need to look beyond the basic hydromet services, because the times are getting very tough with a lot of private agencies also throwing in their hat, and there's a lot of explosion in terms of the technology options being made available. So what I think would the national forecasting agencies need to have is a digital phase for themselves, just to catch up with the times. So the external forces that impact, that extract the demands from national forecasting agencies, I think, are the population growth, increasing urbanization, and of course the technological revolution in communication, and the sheer unpredictability of weather, and the explosion in terms of diversity of weather services being made available the world over. So they set up a very complex scenario out there, and the national agencies may find it very challenging to meet all the needs of all the people, all kinds of end users across sectors, across regions. So it calls for so it's likely that the government by itself will need to come to the IMD for advice and support, just to reduce the risks from future weather events, which are increasingly getting very unpredictable, as I said earlier. So more and more would be expected of national forecast agencies such as the IMD going forward. So the question is, are we ready yet? And how fast we can catch? It's all happening. You have connected devices. You have all sorts of weather apps on, taking their place on the mobile screens. So it's just a question of being able to make ourselves visible in this entire, scenario. So this, I think, calls for ingesting and assimilating interdisciplinary sciences, knowledge, experience, and expertise. They're all available from across the platforms. If you go to different streams of science, for instance, the art of science of effective weather communication, sociology, and even psychology, when it comes to prepare people to receive the weather communication, the weather alerts and warnings as they come, and make them pay heed to the alerts and warnings as are available, and prompt them to take action in time. Because I think there's a gap between the alerts and warnings being made available and people, response from the people. It could be a geographical systems, it could be an issue of lack of climate literacy. Again, that needs for agencies like the IMD and its sister agencies to reach out to them and educate. And it's a constant exercise. It should go on through. You can this webinar. I think it's a major this kind of interfaces with people with the stakeholders in the climate and weather spheres, and the farmers associations and sector-specific activists. They all can come and interact with the forecast agencies, and that's what makes them involved in the whole exercise. So so I was just mentioning about interdisciplinary sciences, including social sciences and even psychology. So these aspects would need to be immersed in the warning systems. So this calls again for recruitment of hands from these areas, or even or otherwise collaborating with them on a sustained basis, so that we can include these aspects also into the forecast exercise. Again, partnerships with other agencies in the public sector and the academia, as well as the private sector, would mean a lot here, because IMD, going forward, IMD or even the national forecasting agencies in the third world countries, on their own may not be able to provide all services to all people all the time. So it would need collaboration across the platform, across sectors involved, and because that way, I think you can share the expertise, experiences, and knowledge among all these players, which will be to the good of all concerned. And Dr. Mohapatra, I just wanted to also mention about the technology aspects. We are witnessing artificial intelligence, machine learning, and Internet of Things, IoT, being employed on an increasingly, increasing basis, and which will make available hyper-local forecasts. So I think that's where the world is going to get the weather forecast in a hyper-local area. So the national forecast may not be relevant for a particular area at a particular period of time. So in case if we need to have hyper-local forecasts, we should go and look to have the most advanced technologies available, just like AI, ML, and IoT. That's why, and I earlier said earlier that we need to have a digital capabilities to be developed at the earliest. So as Dr. Gupta said, the forecast on what weather will be is not the main issue. It's about what the weather will do, which shifts our focus back to impact-based forecasting, which Dr. Mohapatra was mentioning about, which I think is a very welcome development. And again, it's all about providing the right information at the right time to make the right decisions. So the forecast being made available doesn't hold any value unless it enables decision making. I think that's the most fundamental thing that needs to be underlined in this context. Thanks very much. Thank you.
Thank you, Mr. Kurian. I think you covered a wide range, in fact, of areas. So fundamentally, your intervention is that IMD doing otherwise very good, but I think they don't need to go. So you need them to improve their outreach, also make it more technologically advanced, and also especially you mentioned AI and IoT, that's, I think, already work has started doing, across the world. Many private sector companies have already started working on AI and IoT based forecast system. I think that's very, and also you very rightly brought out the issue of, partnership. I think we will discuss this again in the next round of discussion. But very important that no agency, however, worthy it is, cannot work alone. So it has to work in partnership. And so much new challenges are coming. You mentioned urbanization is also increasing. So anyway, these are issues. I will come back to some of these points again in the next round. Thank you very much, Mr. Kurian. Let me now go to Professor S.K. Dash. Professor Dash, I'm opening this question. Of course, we are going in the next round. Little bit. I need very brief comment on how do you see challenges of climate research in the country, and especially in the context of climate modeling. What do you think are the big challenges, and where do you think that India can, in fact, work and come up with some grand ideas in the area of climate research? Professor Das.
Thank you, Dr. Gupta, and namaskar to all. Good evening to all of my participants. I thank STIP2020 for getting me into this important discussion. You see, you have heard from Dr. Mohapatra about the progress we have made in weather forecasting in the country, which is very, very commendable. And people also believe nowadays what the IMD says. These are all happened thanks to the initiative taken by the Ministry of Earth Sciences in enhancing the observatory network, having new type of equipments, and also emphasizing on the modeling part with the help of its institutions at different places in the country. And next you heard about from Mr. Kurian, what is the expectation from the people? There is social science, psychological science, and all this. So now I will build on all this by saying that climate science is interdisciplinary, and it affects the entire gamut of the society, like agriculture, food ability, human health, even ecosystem, biodiversity, everything is affected by the climate change. And on the other, also, in addition to this also, this is a subject which is interdisciplinary. Here, every scientist has some contribution to make from different domains, biological science, chemical science, even space science, because now they're thinking of including the space science into the Earth system models and all these aspects. So we have demonstrated as a nation that with the target, well prepared target, we can achieve that. We have shown that in the last 10 years. And we can have high resolution models, observation, we can have very good data assimilation, and we can give forecast to certain sectors very precisely, or you can say of the standard of the world, international standard. So now the question is that what are the challenges? Challenges have to be set. The present status in mind and also keeping the objective in mind. What is the objective of climate science? Climate science objective is to reach the people and to help the people and serve the people. That is, the COVID-19 is the best example, and we have to learn a lot from this. Preparedness. COVID came very fast and spread very fast. COVID came suddenly and spread very fast. Climate change science is known. It has been discussed for the last so many years that there will be warming, that there will be extreme events, etc. These are known for the last so many years. But the only problem is the preparedness. But advantage is that we're also getting time in some cases. Extreme cases, the forecast is good, and in global, this day-night changes, temperature, etc., we can have some years data and prepare ourselves few years. So climate change, in a way, we can tackle it, provided we are ready to change ourselves. That is a separate question. That mitigation, connected, all those very, very complex matters beyond the comprehension of the scientists. But I would, under the present circumstances, what we can do as a nation, I'll just flag certain 5 to 6 points. First thing is the modeling, because most of us are working in modeling now, and we have got the benefit of using a model at different time scales and with different resolutions. But we also know that none of the models are very good, in a sense, even reasonably good for India, to a very, very large extent. I don't want to give the figure here. It will be very alarming at certain place what is the percentage of error. Although the IITM R system model, which is our flagship, that we have shown that we can convert a couple model timescale prediction to an R system model by including sea ice and ocean biogeoscience, chemistry, etc. We have to also include many more things like plant ecology, continental ice shelf, etc. There are so many other things to be included. And first is to reduce the error in whatever models. And we should also remember that there are nations where they don't have the modeling capability, but they're able to give some forecast. And climate service can also make, because there are so many models available in the world today. So what we should do is that we should be worried about having a model for our country where many scientists can participate, number one, from the university sectors and young scientists, wherever they are working in research institutions, in addition to the MOES organizations, and for new techniques, which are already some part is demonstrated, like artificial intelligence, machine learning, Internet of the Things, quantum computing. Quantum computing is far behind, but many companies have shown, private companies have shown that artificial intelligence can be judiciously used to go for early warning system in local cases, certain disasters. So can we use these things to enhance the simulated fields of the models, existing models, and reduce the error? That is the most important thing. Second part is that which you are facing, academics, people, even in the government sector also, when you recruit scientists, we get this difficulty that we have to attract more young and bright students from other fields. As I told, other fields are also important in climate. Climate as such, only modeling part is a small part of the whole business in climate science. So we should have biologists, we should have chemical scientists, we could have computer scientists, we should have space scientists. Question is how to attract them. That is a very, very important question. Can we tell them, inform them, and somehow spread the news that there are challenges in our climate science, which they are capable of efficiently managing, and they should contribute. That is the challenge, attracting the young and the bright to climate science. And third part, I would say that, as I mentioned earlier, there are models available from the world, IPCC models available, and there are many other organizations also where they are producing this data, giving the future predictions, and also their observed data platforms. Freely, many data are available freely. All these data are not useless. Although there are errors in the models, one can judiciously find out that certain robust climate signals can be obtained from these with proper scientific thought, and actionable climate information. For actionable climate information, this can be found out from these models. That is the third challenge. We have to take help of advanced method of downscaling, statistical, even dynamic downscaling, and so many other factors, statistical many factors are there. I don't want to go into details like this. Another point I would say, in case of climate, just like in case of COVID, we should learn from that, the resilience building is the most important thing. We should prepare ourselves. Even if the good results will come out, very accurate results will come out from the climate models after a lot of efforts by scientists, I'm not very sure whether those information can be just like passed on to the society so that the society will be benefited. So we should think scientifically, how can we use this in the healthcare, taking precaution in healthcare, agriculture, disaster management, energy production, transport safety, tourism. How can you make all these sectors resilient to the imminent changes? Because it will not come suddenly like COVID. It will give time, and we are already working in that line. So we can use this to build resilience in important sectors in the society, which may vary from region to region. So regional aspect is the most important thing here. Another point I would say, climate engineering, which is coming up in the world very well in many places, even in India also. Carbon capture is only one, that is the carbon dioxide removal, one process. There is also solar radiation management. Those modeling results are available, and many more experiments can be done by to understand the mechanism of this solar management and controlling or giving suggestions for the climate change changes. Then last but one, in my opinion, is this last one, but not very unimportant. It is also very, very important, but beyond the, again, realm of the scientist, that is the PPMO, which Mr. Kurian and Dr. Gupta also mentioned. See, this is happening because we have heard in the IMS for the last 2 years, we have been trying, and I have talked to many international scientists on this regard. It's a problem. It's a real problem because there is a government sector, there is a private sector, there is academia. Academia also contributing to the research, and I don't apprehend that there will be more problem from the academia. They can fit into either private or the government. Only question is that how to bridge the gap between the public sector and private sector. Both want to join hands. Now the question is, there are a lot of research also. I have read some papers where there is separation of responsibility is the most important thing. The private sector should not repeat what the government sector is doing. There should be clear demarcation.
I think we lost contact with Dr. Das.
Have you lost contact? Hello?
Please go ahead.
Yeah.
Professor.
What I was telling that although there is intention of the PPA to work together, there are difficulties, practical difficulties, because there is no separation of responsibility. There are a lot of discussion internationally how to separate the responsibility with the help of the local government. The national government, I mean. So government can take care of some valuable things like data management, having the data with them, and important research activities, modeling, etc. Private sector can do about disaster management in particular sectors, localize, and so many other things. We should realize that the government is, or the public sector, is community facing, whereas the private sector is industry facing. They have to take care of the business because they are doing business. So there should be clear guideline how to separate these, and there should be proper forum. Like internationally, there are forums. If I get chance, I will tell later on. Internationally, WMO and Global World Bank, they are making efforts to have communities together. That's a very, very important thing. And we may initiate at this stage as in India as a combined workforce, and see that it properly works. In my opinion, the private sector is trying, sector is doing. That is why the main problem is arising. There are certain things which are ideal for government to do. There is ideal that it should not be done by the private sector, and vice versa. Okay, thank you so much for the present. I think if I get chance, I will speak later. Thanks.
Dr. Gupta. Thank you, Professor Dash. Dr. Gupta.
Yeah, I think I lost connection.
Seems so. It's perfectly all right. It's perfectly all right.
Thank you. Thank you, Professor. I think you touched upon the important issue, especially the processes and the how do we reduce the errors, and then about the regional modeling and climate engineering and so on. So we'll come back to this discussion after next round. But let me inform that, in this panel discussion has number of, participants so far, and highest number of messages and views have come. So this is a record for so far. Let me go to the next panelist, Dr. Anamika Bharwar, and let me ask question that, since you have been working the area of, climate change and also the social and political and economic areas. Okay. So let me ask, what do you think that going to be the projected scenario of water security in the context of climate change? And how do you think, different parts of the country which are going to be more critically affected, especially in the context of groundwater, because that will have direct impact on agriculture as well. So, Dr. Anamika.
Thank you for having me in this panel. Before I answer your question, I am so glad that all the panelists spoke about the need for interdisciplinarity, particularly when we talk about challenges posed by climate change. And I think that it's a great, although it's a great challenge, but it is extremely important that we do have an interdisciplinary lens when we talk about climate science and climate research. Coming to the question that you have raised, yes, water is a sector where my heart lies, and I have been working in the sector for the last 10 years. If you talk about water security, particularly now with the uncertainty of climate change, it is definitely a huge challenge. Several reports and several studies have already kind of come up with a projection, and which basically tells us that at the moment, while India is going to be in a water stress level, it might move towards a water scarce level by 2050. And that means that water levels may fall to less than 1,000 cubic meters per capita, which is very alarming. And there are several reasons behind it. It is also interesting that in a country like India, the availability of water itself is so diverse. As you asked, which are the regions, and if you see that there are certain parts of the country where you see water scarcity more from a physical scarcity point of view, where you see that water is actually difficult to get access to, or it's not available. But there are other parts of the country, particularly from where I come, from the Northeast India, you see that we do have water, and there is no as such physical scarcity of water, but then there is economic scarcity of water. Where the water accessibility of water is an issue, lack of infrastructure is an issue, and also to some extent, overall, if you look at issues related to water mismanagement of water is also a big concern. And all of these things are a big challenge to water security, and it becomes further challenging when we bring the impact of climate change on water resources. Water is one such resource which has both direct and indirect impact of climate change. Directly, it will have an impact on the resource itself by reducing the availability and also having an impact on the quality. And indirectly, it will have impact on several sectors on which water depends, and definitely one of them is the agriculture sector. Coming to the groundwater, I mean, I think we will all be on the same page here when I say that it's overexploited, mainly in northwestern and western and peninsular India. Groundwater extraction in some of the states like Delhi, Haryana, Punjab, Rajasthan has almost reached 100%. And this will definitely be a huge challenge, not only for actually agriculture, for several other sectors, and also it will have a big challenge with big ramification of the livelihood and the whole economy. So we definitely need a legal framework to regulate it, which is unfortunately missing at the moment. And I also very strongly feel that when we talk about water, water cannot be really seen as a single resource, because it is linked to several other resources and several other factors. And so I would definitely emphasize that this whole idea of food, water, energy nexus needs to be understood well. And we need to have now policies which brings these different sectors together. Otherwise, we also see that at several times we may be doing a lot in improving water efficiency, but they may be energy inefficient. And on the other hand, we may be trying to focus a lot on energy efficient technology, but it might be highly water intense. So these, and this is why I feel that interdisciplinarity is a must, particularly when we are talking about issues like climate change and resources like water, which has multiple users and multiple facets. I will stop here and I will wait for the next question. Thank
you. Thank you, Anamika. I think we'll discuss about the water policy issue, maybe more in detail in the second round. Am I audible? Is that okay? My voice is fine.
Yes, Dr. Gupta.
Yes.
Okay. So, thank you. Let's now go to the next panelist, Dr. Mamta Sharma. And so, Dr. Mamta, you have been working in the area of agriculture, for quite a long time. And therefore, I would like to focus, is Nimita, I'm okay? Am I audible? Is that okay?
Yes, Dr. Gupta. Yes.
So maybe I will ask that question is again. So how do you see that India is meeting present and future demands of food grains in the context of the climate change, especially with the change in temperature as well as the extreme weather events that are increasing both in their number as well as their intensity. And what are the key challenges that you see in the area of climate change? Over to Dr. Sharma.
Thank you, Dr. Gupta, for this question. And thank you, Dr. Gupta and Dr. Nimita, for giving this opportunity to share experiences on the research in the area of the climate change in agriculture. So as we heard from the fellow co-panelists that the climate variability is happening, and then the impact on the agriculture sector is definitely there, and it's going to be the major factor impacted by the climate change. I would like to start this answer by looking at the growth of the agriculture in the past 6 to 7 decades. We know that the food production that was around 50 metric ton in the 50s and the 60s, and now it is around 300 million metric tons. So there is a significant agriculture production, particularly the food grains have grown enormously. And there is a contribution of that. A lot of advancement has happened in the area of the research and development and in the technology when we are talking about the high yielding crop varieties, and a lot of infrastructure in terms of the irrigation facilities, and several policies in the area of the crop production processes. So that has given us a huge impact on the agriculture production. But at the same time, what we are looking at, there is a degradation or the ecological imbalances that is happening, which is impacting the sustainability of the agriculture system, you know. And now we heard that a lot of climate variability is happening, and that is another layer of complexity on the climate change and agricultures. When we are looking at the impact of climate change variability in agriculture, that what we have seen, the kind of experiences or the R&D what we are conducting is that indicates that particularly as Dr. Gupta mentioned, that increased in the temperature, which is leading to the drought, and we have seen a frequency of occurrence of the drought has increased in past 1 decade a lot. That's leading to a soil moisture stress. And then we heard that there is a lot of uncertainty in the monsoons, and we know that the agriculture and the weather, those are the integral part of each other. We cannot separate them. And then there is a lot of things that is happening in terms of the increase in the greenhouse gas emissions, particularly the carbon dioxide, which is another component that is added to the agriculture production, which was never an important area earlier. So all these factors, when we talk about the increase in temperatures and then erratic rainfall distribution and increased greenhouse gas emissions, these all are impacting the crop production and also leading to, I've seen recently, the outbreaks of the several pests and diseases, which in turn is leading to the losses in the crop yields. So these are quite challenging impacts of the climate variability that we have seen. But there is a research that has already initiated in some of the institutes in India, and globally there is a lot happening in this direction. Although we are not there, but we are just in the beginning phase. But still, we are getting some kind of a preparedness for that. And I would like to share some examples here that we have seen in the R&D, what we are conducting. Like in case of the crops of the wheat and rice, which are the 2 major crops of the staple crops when we talk about the country like India. And in that, there is definitely these are the quite vulnerable crops when we talk about the increase in temperature. We have seen that if there is a kind of 0.5 to 1 degree centigrade increase in temperatures, we see a decline in the wheat productivity of around 0.5 tons per hectare. So if you look at over the larger area, what we have in the wheat producing area, this impact is going to be huge. Similarly, when we talk about the rice, we are working with the rice research institutes, and then as Dr. Gupta mentioned, that there are several programs that have been initiated by the Department of Science and Technologies, and several other schemes are there, wherein a lot of effort is being put towards generating the strategic knowledge in the area of the climate change and crop production. Then in case of rice, what we have observed that the thermal stress as well as the water stress, those are working hand in hand and is responsible for decline in the yield, and that will happen more when we enter into the future, more climate variability in terms of the temperature and precipitation. When we talk about the crops, like other crops other than the wheat and rice, for example, in the crops like chickpea and pigeon pea, like pulses, these are climate resilient crops, but there is a resurgence of some of the pest and disease outbreaks, which were never known to be the important one. Those are triggered by again, the soil moisture stress and high temperature, and then high rainfall distribution during the intensity of the rainfall when it is increased within a few days. So these are some kind of the challenges that we are facing now in the area of the climate change as well as the agriculture. What we need at the moment is, as some of the co-panelists also mentioned, preparedness is the key. Preparedness is definitely the need of the hour, and we should look into this area. For example, there is definitely a need for reorienting the agriculture, what we are doing. A lot has to be done towards the reorientation of the cropping systems. There is a need to bring in the climate resilient crops. Rather than the wheat and rice, some of the focus should be on the crops like the millet and the sorghums, which are the hardy crops or the climate resilient crops. Apart from this, there is also a need in terms of the more investment. More investment is needed in the sector of the R&D We are not at the stage where we have an infrastructure to conduct all the kind of research that is happening in Advanced Research Institute. To reach to the level where we can say that, okay, this is the strategic knowledge we have and that it should go into the policy forming. So we are still in the era of the climate research where we are working towards reaching to kind of the preparedness in this area. Also, I heard that there was some discussion happening on the forewarning system in terms of the climate. So that is a very important area for the agriculture. And if that can be convergence of the interdisciplinary teams, again, there comes several actors here. Not only the agriculture scientists, but definitely the climate change experts, modelers, and practitioners, extensions. All these need to work together in order to come up with some innovative solutions to deal with this climate variability impacts. Definitely, and then also I would like to mention here that capacity building or the empowerment, that's another area which we are lacking so far. And there is a need for a lot of investment in that direction, wherein not only the farmers, but there is a need of the exposure training programs for the scientists or the researchers also. Definitely, there is a need for the young researchers to push in this area of the climate change. And if agriculture, I will say must, because the youth, it's very difficult to attract the youth in the area of the agriculture. So there is a need, there is definitely a need, and some kind of policy reforms and some kind of investment is needed in the direction so that we can look towards the food security and the nutritional capacity in that directions. So with this comment, I would like to stop here.
Thank you, Mamta. Very important points on the climate change impact on agriculture area. I think we'll have in the next round, we're going to come up more discussion in this thing. Let me now go back to again Dr. Mohapatra. And then I wanted to ask a question on the climate services that I think Dr. Dash has already covered. So and we are running behind the time. So let me go for a somewhat different kind of question, where as Dr. we so progress in the area of weather modeling and now in fact we are already moving in a direction. So the kind of that taking place across the actually two big things are going to happen. This is what I read from the NWS vision. That there's going to be something like a satellite data ingest and assimilation, and all kind of just not geostationary but also the low Earth orbiting satellites data and all. In fact, the NWS vision says that these data that are going to come are going to land surface much more accurate way than earlier, and then also the data that for the even data. So there are two things that coming into this kind of context. That there is a statement of the National Weather Service US saying that the satellite data in the time to come are going to replace all instrumental observation. So I think that a big vision has been put that all instrumental data will be replaced with satellite data. Second big thing happening is the computing side. So quantum computing is going to change the scenario altogether, and therefore we will. We have been thinking of having 100 petaflop computers and all. We're going to have a big jump into the computing resources, and therefore we are going to have much advanced and much finer resolution model with better satellite data ingest. Again, a new vision coming up, where saying that we soon can have 1 kilometer resolution model at lower scale. That is giving a vision that with that model in place, the 3-day forecast is going to be correct. And therefore, and they're saying that we run this global model 30 days. How do you think that the kind of unprecedented modeling advancement that is going to take? And how are you going to cope up with the whole thing? And don't you think, this is a fundamental question I'm asking, don't you think that such big changes that are going to come will allow the limit of predictability that we have been thinking of? So anyway, this is a long question that you can answer it as per your Dr. Mohapatra, over to you.
Yeah, thank you, Dr. Gupta. Yeah, you have correctly pointed out the expected need and the vision that should be with the National Weather Services. And many of the points also has been discussed by Dr. Das and Dr. Kurian. I just want to mention here, yes, the Ministry of Earth Sciences has prepared the Vision 2030. And it is an ongoing process. You may come up again after some time, the Vision 2040 also. So I would just like to state one or two specific points with respect to climate before I respond to your questions. Am I audible? Okay. So I just want to add what Dr. Das has told about the climate services and modeling and research, that we have moved from simple climate data monitoring to the climate modeling. We are having at present the state-of-the-art climate model for providing monthly and seasonal forecast, as well as the climate change forecast. For the first time in the country, you will be happy to know that Minister of Earth Sciences, through its Center for Climate Change Research, will be submitting the model output for to WMO and IPCC for consideration of our guidance with respect to the climate change. At the same time, I will be happy to inform that we have also moved simple provision of climate data to the various users to the climate application services. There are services with respect to hydrological sector, especially for day-to-day monitoring of floods and drought conditions, or seasonal monitoring of floods and drought conditions, and also the river management system. We have introduced the health sector, especially for diseases like malaria, dengue, and also we have tremendously applied our climate services in agriculture sector with the help of seasonal forecast and extended range forecast. But still, there are a lot of things which has to be carried out. We have already listened that we are planning and already in the process to introduce all the application sectors and to provide the better and improved services in climate sector as per the global framework of climate services. We have now a national framework of climate services, and we'll be providing that. To carry out this, we have to improve all the components like observations, modeling, forecasting, and applications. As Dr. Gupta told, we are moving in the direction which is the globe apprehending during the next 10 to 15 years. If we look at, we have to move from the present practice of forecast, which is a man and machine interaction, to a digital forecasting system, where not only up to 3 days, but even up to 5 days or up to a week, we can directly provide the direct model output, which can be utilized by the various users and sectors. To have that achievement within the next 10 years, which is the goal or the vision, we have to improve our observational systems. It is true that the conventional observational systems cannot address the requirements to achieve this goal. There will be need for the non-conventional observations, role of more satellite data, and also the other observations like radar. And at the same time, what Dr. Kurian was telling, some kind of crowdsourcing data will play a mega role in this particular exercise in collection of data. At the same time, we need the sustenance of the traditional observational systems to ensure the quality of these non-conventional data and to the quality of the climate and climate change aspects of research and development. So this data will help us to proceed further to have the better modeling system. For your kind information, Minister for Sciences has come up with the models with better data simulations and higher resolutions. And at present, if you compare 10 years before, we have got only one limited area model providing the forecast with a resolution of 120 kilometers. But at present, we have got a model which provides the forecast about 12.5 kilometer resolutions. And the forecasts are being provided 10 years before with a lead period of about 2 days. And at present, we are providing forecast of 10 days. The accuracy, if you just look at it, has increased the manifold. So immediately, the plan of Minister for Sciences is to improve further from 12.5 kilometer to about 5 to 7 kilometer during the next 2 years. The ultimate goal for 2020-2030 will be a global model with a resolution of about 1 to 3 kilometers. There is an analysis, there is a discussion or interaction. If we go for a global model with a resolution of 1 to 3 kilometers, whether there will be need for any mesoscale models. So the science has to improve, therefore, in the coming days to go for addressing the mesoscale phenomena in the global modeling scenario so that no severe weather event goes undetected and goes unpredicted by at least 2030. So, to carry out that, yes, as you told us, the new computing processes are coming up. Quantum computing will having a major role. At the same time, apart from the conventional modeling processes, which we are continuing worldwide, like numerical modeling and climate modeling, there is scope at present to introduce the non-conventional ways like artificial intelligence and machine learning for predicting the weather and climate and various applications in this sector. The science of artificial intelligence or artificial AI/ML is not new to our country. It has been applied earlier, but over the period of time, with the increase in data volume, with the role of the big data, now the AI/ML has gained the importance. At the same time, also the computing and the approach towards AI/ML has changed over the globe, and therefore there has been specifically 3 applications of AI and ML. One is the decision making. Now, as present, when we say that Minister for Sciences has 7 numerical regression models being run every day, twice or 4 times, so how to take a decision about the severe weather expected over a particular city or a particular village or a particular time? At present, we go for downscaling with the help of a regional model or the mesoscale model. But in addition to that, we can go for the downscaling and location-specific information and decision-making with the help of these AI/ML tools and other tools to come up. Similarly, for the various sectoral applications, not only the direct sectoral applications as we deal with in India Meteorological Department, but other sectors as it has been brought out during the discussions, we can also utilize this AI/ML to have the tools for applying this weather and climate applications in these societal sectors. The third thing is that in the seasonal forecast also, and the seasonal and extended range forecast, also we have got a number of tools at present from various research and development agencies and operational agencies. There is also scope to utilize a mix of dynamical and statistical information in the past data, which will help us to have another way or approach of forecasting. But globally, there was a discussion recently. We'll find that the numerical weather prediction models cannot be replaced by the artificial intelligence or machine learning. Both will go parallelly, especially in the nowcast scale. The forecast for next 3 hours or 6 hours with respect to severe event like heavy rainfall or thunderstorms or lightning, the AIML will have a major role in addition to the mesoscale modeling. Similarly, it will have certain role in the seasonal forecasting. But with respect to the medium range forecasting, this forecast from 3 to 10 days, still numerical weather prediction modeling is the only source and will continue to remain the only source which may be supported by decision making by the AML in the near future. So therefore, we have to go on continuously improve all aspects of numerical weather prediction modeling, especially with respect to collection of observational data from various conventional and non-conventional sources. And also we have to go for better data assimilation systems, and also better post-processing and various development of the products which can be directly utilized. As Dr. Gupta was telling, yes, I am also sure the time will come, perhaps by 2030, the forecasters will have only role to interpret the output of numerical weather prediction models. They will need not go for forecasting. They will just interpret the output and provide the value addition to the various sectors in socio-economic development. So gradually, I feel as we go from 2020 to 2030, the accuracy and the lead period of numerical modeling will improve in such a manner that it will be completely a digital forecast for various sectors. And by that way, the forecasters will be in a position only to smartly interpret the output of the forecast and provide the guidance to various sectors. So while doing that, there will be increased demand in various sectors. So at present, actually, we have identified 8 special sectors. Like I have given an acronym like UPHIT. U stands for urban sector, P for power sector, H for hydrology, and H for health, E for environment, A for agriculture, and T for transport. When I say transport, it includes surface, air, and navigation. So in all these sectors, the more and more intervention will be needed with the socioeconomic sectors by utilizing smartly all these informations from weather and climate. As I was telling in the beginning, yes, impact-based forecast will be the ultimate goal, because we have come up to a stage where we have limited the number of deaths due to cyclones, due to heat waves, due to cold waves. But still, there are certain challenges in sectors where we are not able to minimize the loss of properties. Therefore, impact-based forecast will be a major goal for 2030. And for this purpose, we need an integrated approach. Only Minister for Sciences or India Meteorological Department cannot provide the impact-based forecast. To provide the impact-based forecast dynamically, which is actually dynamic because of realistic information changing from every minute while there is a heavy rainfall leading to floods or while there is a cyclone crossing the coast. So therefore, what we need actually, there will be 4 specific players for this impact-based forecast. One will be the early warning service provider like India Meteorological Department, Central Commission, INCOIS, etc. will provide more and more accurate forecast, because without accurate forecast, you cannot provide impact-based forecast. Then you need some kind of geophysical parameters. So for example, when there will be a particular hazard, it will lead to a multi-hazard. For example, taking a cyclone, you will have a multi-hazard because of landslides, because of the diseases also, but there can be impact in terms of flood sectors or hydrological sectors. So you need a multi-hazard scenario, and therefore there will be need for geophysical hazard assessment also. The third requirement will be the geospatial information. So therefore, geospatial technology will play a major role. The fourth and most important is the socio-economic indicator. You will need information about if a particular city is going to be affected by the urban flooding. You need the information about the drainage system. You need information about the slums, the type of houses, population density, and other socio-economic information. So all this information has to be integrated in such a manner that there will be multi-layered information put together to have a better decision making by the disaster managers and the stakeholders. So this is the ultimate goal. India Meteorological Department and Ministry of Earth Sciences are working together with various agencies. We are open to partnership with all academia, R&D institutes, and also the private sectors. There are very good examples where India Meteorological Department has come up with partnership. One of the examples is our aviation sector. Second example is the agriculture sector. Third example is the tourism sector, where we are providing forecast to various private platforms also. So we are not hesitant to have partnership with private sectors or other sectors. Only thing is that, as Dr. Das has pointed out, that the sectors should cooperate with each other in such a manner that they complement each other. They should not be in conflict with each other. They should not do the same work simultaneously. With just it is not required. So therefore, as Professor Das has told, I also agree that private sector and public sectors should have a complementary role. And this complementary role model has been demonstrated by certain developed countries like USA. So there is scope, therefore, a good private-public partnership where both will have their own independent role, but complementing to each other. Now, finally, when I come to what will be the broad policy, I feel we should have a broad meteorological policy in the country where you will have the role of various stakeholders. I want to just stress upon here, Dr. Kurian is here. He has been always a supporting pillar for enhancing our services to the general public. So media plays a dominant role. At the same time, media also will have some kind of policy how to strengthen this cooperation and extend further the needs of the society and expectation from the society, and reach out from the servicing agencies like India Meteorology Department, others, to the general public. So therefore, as a whole, I feel that considering the growth of socio-economic conditions in the country, considering the demand for the weather and climate services, we have to go for a meteorological policy to address the requirements, to address the role to be played by the various stakeholders. Thank you very much.
Thank you, Dr. Mohapatra. I think you touched upon almost the entire gamut of the issues, and also you've given your vision for 2030 and beyond. I think it's very comprehensive response from you, and thank you very much. Let me now move to I think another important area, and that is the sectoral impact of climate change, and especially I'm touching two areas where we had not discussed so far. One is the area of climate change impact on human health. So in fact, so much work has been done by DST in this area. Dr. Dash has been leading our initiative as a network program on climate change and human health. Also, the second issue is impact of climate change in the Himalayan ecosystem area. That is a very different and very fragile system, and the impact is different from the rest of the region. So I'm posing these two areas for response by Dr. Dash, because he has been associated with both these areas, and also he has been part of the DST expert committee. So I would request Professor Das to respond to what kind of challenges and the need for research in these two areas. Dr. Das.
Yeah, thank you, Dr. Gupta. If you look at this impact of climate change on human health, it is not less important than impact of climate change on agriculture. But somehow it was not picking up because of so many reasons. That is this, one is called the climate data, the other is the non-climate data. One of the non-climate data is obviously data from the medical sector, from the hospitals and all these things. If you want to connect these two, then you need proper data set. As in case of climate, there are very good climate data. And in case of the health sector, we don't have really systematic and well-connected data from all the hospitals, which is a challenge. So the first network program by DST about 6-7 years back, 5-6 years back. It was with that objective, that to encourage the climate scientists to interact with the health scientists so that some new results will come up. So there we have focused on obvious topics, most important topics we know, like air pollution, heat waves, of activities. But now we have added in the second, it was very successful and the report came out. And now it is two more sectors have been added. That is this water, about the waterborne disease, and this tribal health is also very, very important. So what we found in our network discussions, very, very interesting results are coming about, but there is still the problem of connecting between those sets of data, very less data, and difficult to interpret these results. Like vector-borne disease in the previous case was very well known, and a lot of work has been done in the first network on the climate change impact on vector-borne disease. And very important result came out about the threshold in the rainfall. There is a threshold value of rainfall in different parts of the country which can really affect and which will be forewarning malaria prevalence. And that is going to the stage of early warning, similar like that. And more results will come out. Similarly, for the heat warning, heat wave warning, you know about the Ahmedabad heat action plan, which is they have joined in the second stage of this networking program in DST, and it is going to be implemented in other cities also, 2-3 more cities, and promising results are coming about. This is happening only because of systematic experiment to be done is also planned. Systematic data collection is one part, but there is another interesting thing that in 5 cities in India, there will be a collection of like heat wave really doesn't affect directly as such. Temperature rise has impact on the human physiological aspects. So there were experiments done in the cities that whenever there is declaration of heat wave by IMD, then in certain places some people will be taken care of, and there are pulse rate, what is the respiratory rate, if they drink more water and what will be impact on that, what type of prevention they should take. This type of activities are going on. So this will be very interesting, and I'm sure that this will, I cannot really, nobody can now connect this to the COVID. Climate change is in a way indirectly connected to the COVID, although there are some work, papers are coming about in the social media about the impact of humidity, impact of temperature, impact of wind on this COVID-19. These are all not really the truth. Some part it is correct, some part they are not. But if you look at indirectly, pathogens are the most important things. So when the forests are destroyed, I'm talking of the human health again, that on the larger scale, when the forests are destroyed and biodiversity and ecosystem is affected, then a lot of new pathogens develop, and how they will affect the human health is a question, very big question. So the actual remedy is to take care of the ecosystem, take care of the biodiversity, which is a big question. But so far as the prevention of this is concerned, a lot more work has to be done. So directly connecting climate change to occurrence of diseases, certain diseases like COVID-19, etc., is very difficult. But indirect impact on health, rainfall, vector-borne disease, and directly by heat waves, also indirectly by heat waves, these are possible. And I am sure that Indian scientists are contribute to a very, very large extent. And I think the Himalayan, the DST work which has been done by the Himalayan ecosystem, that is very, very interesting and very futuristic, you can say, because there are all the states in the Himalaya. In addition to that, some other states also. There are state climate centers, and also there are several projects given in the network mode to look after wildlife, to look at this impact on wildlife, for example, biodiversity, to some extent the soil moisture, and different plant species. There are so many aspects of these in the studies in the Himalayan state, and this should generate a lot of data. There are already data existing, and those are being compiled together. In addition to that, this type of studies in the future will give more data so that the water conservation, aspects of the water conservation and similar other impacts on the ecosystem and prevention to some extent by going for local traditions. Another issue is the tradition. Traditional knowledge is very, very important, which is existing in these areas in the Himalayan, because Himalayan zone is the main water reservoir for India. As you know that this is helping a lot to the entire climate system, either from the ocean side or from the Himalayan side is affected. So I think at this stage I would like to say, because some constraint of time, I will not go into details, but these two, as you told Dr. Gupta, these two network programs are very promising, and I'm sure that this is the way to involve more scientists from the region. As I told in the beginning, climate science is not only modeling or the forecast. This is much beyond this, much more than and a lot of other scientists should also be involved in this. And this type of programs will join these scientists together. But one challenge we find is although these scientists in these network programs are very interested to use the climate data, which are freely available and very systematically, they are not sometimes very convenient using these platforms and knowing what type of data they will use from which platform. So I think more interaction is necessary from the climate scientists with other interdisciplinary scientists, and having coordination in making this climate data available. Some sort of data center have to be there. I don't know what is the effort from the government side. There should be one effort where all these data should be combined together, and sort of training should be given to the health scientists and the ecosystem scientists, so that they can use this climate data very whenever they want, getting out a lot of climate information from the by the use of non-climate data. What I mean non-climate data is ecosystem data and all these things. Thank you so much.
Thank you, Professor Dash. In fact, these are very important points coming from you, and since you have been very intimately involved in these two activities of DST, I think, thank you very much. I think we are very, in fact, very much behind the schedule, and I'm sorry, I apologize the other panelists. I need to now, in fact, cut short. My time allotted is already exceeded. So in fact, my co-host Nimita is getting ready with you. I'll tell you many questions have come. This is unprecedented. We never received so many questions. So I think I will hand over to Nimita for any question. Maybe one or two questions she can ask from the floor, because we hardly have much time left. So I'm sorry, Vinson, Anamika, and Mamta, I'm not able to proceed further because we had to close by 8 o'clock. So let me, give it over to Nimita.
Thank you, Dr. Gupta. I would rather say you don't have to be sorry. I know these pre-curated questions. So what I'm trying to do is like, I'm just trying to entwine these pre-curated questions, and I'll throw it to Mr. Kurian about, talking about what I have realized among all the questions that are coming up, that some of the key factors, what people are concerned, where our audience are really putting their questions on some of the key elements of which will be very relevant for the policy. That is about capacity building, then it's about coordination and coherence and participation. So going with the idea of capacity building, I would like to pose a question to Mr. Kurian about academia, because there is a question which talks about, say, how it is important to attract bright students from across the discipline. This was asked, and how is there any chance to expand the subject or of meteorology in the university at undergraduate and postgraduate level? So do you see a prospect there, and how one should go about? Over to you, Mr. Kurian.
The whole point, we need a good, passionate, really interested professionals to come into the field and get them trained as well, not just from the graduate level, right from the school level. Give them the lessons with respect to climate change, because it's already catching up with us. And as we have seen in Kerala, especially last 2 years, we had repeated visitations of major floodings, and which I think is going to become even more frequent going forward. So there's very high priority for students at the school level to be trained and to be told about what is upon us going forward, because we are already seeing the impact of climate change all around. And as far as the academy is concerned, I think it's time for their research and whatever research results that they are coming out with, to go into the value chain, the common value chain, and reinforce the climate research being done by the IITM and other the institutions like the IIC, the IITs. I think it's a very exciting opportunity for bringing them all together into this this network, because India is one of the countries worst affected by climate change. So it's already upon us. I think Dr. Mohapatra made some very valid points with respect to going forward with digitization, digital transformation of the IMD. And also, I'm so glad to hear from him that he is open to partnerships with like-minded agencies and even the private sector, which is I think is a very good way to go about it. Thanks very much.
Thank you. The next question I would like to, since you have already talked about academy, and you talked about how it is important about school level. Now it's all about the science and the part of it. And I see that climate science and climate policy, they are going parallel to each other, but we still need a lot of convergence. And with this idea, I would like to pose this question to Dr. Gupta, saying that how do you see a convergence, and where the policy mechanisms would actually help or enable to bring this convergence between climate science and climate policy? Over to you, Dr. Gupta.
Yeah, thank you, Nimita. I would have loved to have this question, diverted to some other panelists, more worthy panelists. But anyway, I'll try to answer. So basically, this when we had this National Action Plan on Climate Change, And this was the first document. And I am privileged to be the convener of the National Action Plan document preparation. So we had this became kind of policy document. And so how we move into the research area. So we did have research area in the country, research done in the country. In fact, a lot of research has been done traditionally by IND and IITM, and also many institutions like VHU and IIT Delhi and all. They were, we needed a consolidation and focus on research in the country, and going X, multiplying by X factor was needed when we do national missions on focusing on S&T capacity building was brought and given to DST for implementation. And you see, look at the change that has happened. 10 years before, we would count the number of institutions and scientists working in the climate research area. And today, we had 3,000 scientists working in the area of climate research in the country, 450 institutions working in the area. That big change has come in the country because of, the big initiative that DST has brought as a part of the two national missions. I would particularly say that the mention about Himalayan research in the Himalayan ecosystem. Though a lot of some research done by the various Himalayan institutions, but the research in the university were mere ascent. And so this mission on national mission on Himalayan ecosystem had brought this major focus, and now we have a Himalayan status of Himalayan ecosystem available today. So this is a major change that has taken place in last about 8 to 10 years. We have now 12 Center of Excellence, 23 major R&D programs, 9 network programs, 6 task forces, 25 state centers, several capacity building programs, and so on. And DST alone is addressing, it's actually associated with DST something like 1,200 scientists and 270 institutions, and 600 students are associated. So I think policy has implication. So a good policy has relation to the good action at the level of institutional level. That's all I want to say. Thank you.
Thank you, Dr. Gupta. Okay, I'm slightly moving away from this idea and I'll come back again to this, but I would talk about, since it's all about research, developing technology, we have some interesting oral focus kind of a question. And in context to capacity building, so I would like to pose this question to Dr. Sharma, saying that how do you see a way forward in training the resource people? You are sitting in ICRISAT, and how would be the use of technology, particularly say AI or ML, in agriculture in context to say climate change or weather forecasting? How do you see that there is a way forward to train the resource persons who are sitting in these institutions? Over to you, Dr. Sharma.
Yeah, thank you, Dr. Nimita. This is a very interesting question, and we always keep on debating about this capacity building and the training activity, how to enhance or the capability of the different institutes and the infrastructure in the different institutes to move towards the digital technologies, particularly the AI and the machine learning. Although we have just in the beginning, I'll just say in the agriculture sector, it is the AI and the ML kind of technology. The digital technologies has just initiated, and we need to learn a lot in this area of digital technology, particularly taking it to the farm level. So when I say about the capacity building, as I mentioned earlier, it is the capacity or right from the scientist. not only to the students and all, but even the scientists who has to teach about these technologies to conduct the research and development in this area. Definitely they should be first exposed to these kind of technologies from the advanced research institutes. There should be some facilitation or some kind of the policy reforms or support services from the government sector in this direction to give some kind of training programs or the workshops wherein those young researchers can be trained in this area of AI and machine learning particularly, or in the modeling area. I'll say the crop and the, for example, the crop and the pest and disease modeling area are have not done much so far. Although these are the areas which are very, very important, particularly for the agriculture sector, and when we have to link it with the forecasting model or the climate change models. So there is definitely convergence is needed from the climate change specialist as well as the agriculture specialist or the biologists, wherein they can work together to come up with some innovative solutions. What is happening at present is that we are working, or everybody is working in the silos. They have their own area of research and everybody is looking into their individual area and trying to work in that direction. When it comes to the level of the convergence, very little is there. And that's the reason probably we are lacking behind. And definitely a move is needed wherein together the workshop or the training programs are conducted where all kind of the actors or the players are there working together to find some innovative solutions. So I think we should take a lead from some of the advanced research institutes. If the capabilities are not in the Indian, then we have to look for the international research institutes, and ICRISAT and some kind of international institutes can help in that directions because we have a global reach, and that can be very useful for connecting the global community together in the area of all the digital technologies, which will be really useful for the precision farming when we are talking about the small or marginal farms. So that's briefly what I would like to mention about this.
Thank you, Dr. Sharma. I will take a clue from your answer when you say farm level, when you talk about interdisciplinarity, bringing about, and I would like to pose this question to Professor Barua, saying that when you talk about bringing these community level, stakeholders into this picture and talking about the nexus of water, food, agriculture, energy, as you have already mentioned in your debate, how do you think that these communities add into this capacity building or capacity development process in, say, climate change and, say, weather research? Over to you, Professor.
My experience tells me it's a two-way process. We usually feel that we are building the capacity of the community. And we basically feel that the knowledge is at our end, and we are basically disseminating the knowledge. But from the experience that I have, I think there is a lot that community also teaches you. So this has to be a two-way process. That would be my first point. The other point is that when we were talking about policy, we need to very clearly understand that whose capacity we want to build and what capacity that we are trying to build. Several times we design our programs, we design our workshops without understanding the kind of need that exists when we are talking about building capacity. I would like to cite an example here of one of the projects which we did recently with DST, which is coming up with a vulnerability atlas for the entire India. This was an excellent exercise because here it was not only just the researchers like us sat together and developed, atlas. It was exciting because we did not do it alone. We invited stakeholders from each state, where different stakeholders came on board. There were around 150 state representatives altogether from all different states, and they were of from policy making side. So it was a group of interdisciplinary people. And when we finally came up with this whole, when we completed this whole exercise, it was not that we only came up with a report. We also could build capacity of these people who were involved in developing these maps. Today, it is really, really interesting to see that these state representatives who came from different states, particularly from the northeastern states, they are now aware of what climate change is, how do you go for vulnerability assessment, what kind of indicators need to be taken, if you are going for weightage, how do you need to put weightage, that you need to involve community, weightage should come from community. There were so many discussions that happened. And I think that was one of the best initiatives that GST took, and we were fortunate to be a part of it. And we also realized that there is a huge difference in understanding climate change itself between among the Himalayan states itself. Like if you look at Western Himalayan states, there's a lot of progression that has been made, a lot of studies have been taken. The state representatives themselves have come up with vulnerability maps. Whereas when you look at the Eastern India side, the understanding was really different. You know, they were not so much exposed to this kind of science. So it was very interesting to bring again Eastern and Western states together. So even when we talk about building capacity, the point that I want to make here is that the capacity building itself should be participatory and two-way, and we need to be very clear whose and what capacity we are trying to build. I'll stop here.
Thank you, Professor Barwa. You rightly pinpointed, and I think that is one of the objective, or say the main pillars for STIP 2020, to make it participatory and more inclusive and bidirectional. And we are actually deliberating on these things to bring it on. Okay, so from capacity building, I believe that there is an overlap with this idea where we see a lot of question coming about data modeling, which I also see as from the larger point of view of capacity building and data and modeling, wherein I see that I could ask questions to Professor Dash on that, being a researcher in IIT as an academic scholar, if he could elucidate on, well, there is a question like the models are not accurate enough on predicting rainfall during cyclones. And I won't say just cyclones or monsoons or things like that. And this question could also be further answered by Dr. Mohapatra, because his specialization lies with cyclone. So where I see that there are a lot of questions related to driving the climate and weather forecasting, as well as the precision in these models. So where do we lack in that? Over to you, Professor Dash, and then I would like to hear from Dr. Mohapatra on this. Where do we lack in terms of creating better models and having a data infrastructure for better climate and weather forecast, as well as for predictive modeling? Over to you, Professor Dash.
Yeah, thank you. Thank you very much. It's a very, very good question actually you have asked. But not really true that rainfall is not accurately predicted. Maybe there are some differences, and it's a question of time scale. It's a question what time scale we are talking about. Some cases they're better and improving also. What we see from the IMD predictions and the modeling efforts in the country, we have come forward, and there are ways to correct those and being corrected. That is happening. But there is a challenge, still there is a challenge, because today I don't think that modeling, enhancing the resolution is a challenge. Earlier thought that if you enhance the resolution of the model, which was not happening because of less computing power and all these things, then there was a difficulty, including the less data. So now if you go to high resolution, it's not really correct that all the time you will get better results if you think of the resolution, because you have to think of the physics will change, and there will be other problems in taking care of the land surface processes, interaction with the sea, ocean, and ice, and so many other things coming. So there is a very, very complex system where the interactions between the systems is very, very important. So models are not bad, giving bad results because of the resolution, which in future maybe it should be better. Definitely resolution has helped, but it may not be true all the time. we have to take care of the physics, and we have to find out, because there are so many approximations in the models. It's not a straightforward thing that you find a simple solution. It's a non-linear process. And in that process, there are some approximations involved where we use several constants, several parameters, which are climatological values or maybe obtained from different places. If I go to the specifics, it may not be appreciated by the audience. So, but those who do work in the modeling, they know that there are the inherent difficulties. So the main concentration should be on going to the process level at a very high resolution, go inside the model. What are the causes of these errors? That has to be detected. The approximation in the parameter. Is it because of putting the initial data wrong, or it is the physical process are put through some algorithms? So whether that physical process they have thought of is wrong, how the cloud is developed, what is the depth of the cloud, how it matters, how the soil moisture is impacting. These are physical processes which are to transform into some parameters. So these type of specific errors in the model have to be found at all stages. And it is shown, some studies have shown that even artificial intelligence and machine learning can help in identifying these errors in the model and rectifying. So that means you are running the model, you are finding the errors in the process, and artificial intelligence element can help in identifying the source of that error. Then you correct that error. That is, in a way, you can call it also, to some extent, tuning. This is called tuning, automatic tuning and manual tuning. There is also mixed tuning. And some modeling efforts have shown that if you go for a particular type of tuning, then these errors reduce. So it's an involved thing. And this can only be done if, that is why I've been telling that there is a necessity of giving the opportunity to the young scientists from different fields to work on a model. On the model, community model, they simulate, they learn in the process. And they may be from different fields. For example, I went to one institute, a computer scientist student came after the lecture and told that I want to use artificial intelligence because I am good in artificial intelligence. I want to use that rectifying the errors in the model. He has no opportunity to do that. And we, as a nation, we should try to enhance our infrastructure such that any young scientist who is interested, Dr. Kurian told that it should be introduced at the school level. From the school level, to enhance the scientific temper of the student towards this science, then probably this type of, and the students get the opportunity to work on the model and go into the details of the code. Model code, as Dr. Mohapatra told, a time will come where the model will give the forecast and the forecaster will have the job of interpreting those results and giving to that. So this type of, that means models will be the real tool in the future, which will help in all respects. So those has to be corrected. For correcting those errors, at local level, you have to try by involving young scientists. That is my feeling. There's a shortage of time, as you told, so I'm not going into further details. I wanted to be as brief as possible. Thank you.
I would like to have quick comments from Dr. Mohapatra. We are already in short of time, but yes, please, sir.
Thank you. As I thank the questioner. Yes, as I told in my earliest intervention, that mesoscale events are still challenging. The occurrence of heavy rainfall, especially during monsoon season, and in association with the low pressure systems like cyclones, depressions, low pressure area, etc., are still challenging. It is mainly because the occurrence of heavy rainfall depends on many parameters. The India is such a country where we have got the Himalayas to the north, we have got Arabian Sea, Bay of Bengal, and Indian Ocean to the east, west, and south. And at the same time, it is fully dominated by various types of orography like Western Ghats, Eastern Ghats, Vindhya Hills, etc. So at the same time, if you just look at the present state of the art model, at present, what model we have got in our country is the atmospheric model. It considers the atmospheric processes. Even in the atmospheric processes, all the processes, as Professor Das told, are not addressed to parameterize in the model. Still, we assume certain theoretical values or climatological values. So real-time assimilation of all the processes contributing to the atmospheric processes are still not yet addressed because of a lack of understanding of the processes and because of the lack of observations in that scale. So when we consider the mesoscale event of heavy rainfall, that means its size is very less. The heavy rainfall does not occur over a large area at any time. It occurs in a small area. So therefore, you need to have in-depth analysis of the clouds, the mesoscale convective clouds. For this purpose, you need the observations in that cloud scale. And also you need some kind of modeling to resolve these clouds. So all these will be possible when we go for that type of observations and that type of modeling aspects. And further, in view of the climate change, I just want to say that there are studies which indicates that in view of the climate change, the water holding capacity, the moisture holding capacity of the atmosphere has increased. If you go by the classical equations, with the rise in 1 degree Celsius temperature in the atmosphere, the water holding or moisture holding capacity of the atmosphere increases by 7%. So therefore, when a low pressure system like low depression cyclone approaches the country, it is also interacting with various processes, and moisture also plays a role. And there will be some enhanced activity of the mesoscale convective events leading to heavy rainfall. But the models have its limitation at present, though there has been significant improvement in the recent years because of the understanding, data assimilation, resolutions, process studies. But still, we have to go a long way to address the requirement in the numerical models. The first and foremost will be the understanding of process studies. For this purpose, some kind of testbed experiments is required, research testbed experiments. You need special observational campaigning. For this purpose, Minister Parsons is taking off the aircraft observations, and also we are going for a special research testbed experiment in the part of central India, just south of the monsoon trough region, to understand these processes. Thereafter, we have to go for the data assimilation, and to prove that by assimilating this understood data, it can improve the model. Till then, by doing so, you may have the improvement in model output, but you need to have further downscaling so that location-specific heavy rainfall warning can be issued. At present, if you look at, though sometimes model can provide the forecast of occurrence heavy rainfall, there can be spatial variation, there can be temporal variations. So all these are the issues, but however, with the augmentation of the observations at the mesoscale, with the establishment of research testbed, by addressing the process studies, and by going for assimilation that particular scale, and going for downscaling to the city and town scale, we can further improve the model efficiency to address this heavy rainfall warning. Thank you.
Thank you, Dr. Mohapatra. In fact, you have answered a lot of questions in one go, to be very frank. I was wondering how to bring these questions, and you have covered.
I just left one point. The model at present also, the land surface processes are not still coupled. Similarly, the ocean processes are not coupled. So ideally, if we are proving to have a better model forecast for heavy rainfall, we should have coupled process of ocean, atmosphere, and earth. So we are working on that direction. So we have already the coupled model for atmosphere and ocean, but now we are planning for coupling with the land surface processes. Thank you.
Thank you, thank you. And I must say that these confessions are very important when you also bring up the limitations, and because that is the way forward to also how to enrich the whole process right now. Coming to something which we have missed onto this discussion, and I believe that Dr. Gupta would be the right person to answer. It was indicated in Dr. Mohapatra's thing that urban weather is the new frontier. And there are questions related to how climate change would will have an impact on urbanization. I would like to ask this question from our moderator come panelist as to answer this question, being a climate change weather forecaster and a climate scientist. Please, sir.
Thank you, Nimita. I think the urbanization and urban climate is somewhat different in terms of impact and its magnitude and even its character than the rest of the climate. So, although the global climate change talks about the average temperature rise, surface temperature rise, and in a general sense, in an average sense. But with the kind of change in the population density and the number in the cities, in fact, we are now in fact having several 10 million population cities are growing, and there is a good, I mean, there is a migration taking place from rural to urban area. Of course, COVID has reversed it slightly, but it's still there's so much urbanization. And this is the interesting thing that we have, that the urban climate has a different character, both in terms of magnitude and also its response also. For example, the in an urban area, in an urban, say, let's say, temperature could be as high as 10 degrees centigrade more than their ambient temperature. It can be as much as that 10. And so the entire, discourse is changing in the sea. So while we are talking about 1 degree centigrade temperature at a global scale, average, you just imagine 10 degrees centigrade in a small pocket of area in a city, how much impact it will have. This is one aspect. Also, that because of the changes in the land use, land cover pattern, entire city now these high-rise buildings and other kind of infrastructure is coming. It's also influencing the temperature of that area, and that is the reason why it gets temperature. There is a recent study which says that in fact there is a correlation between the density of population and the intensity of rainfall in the cities, which means that the cities are experiencing more heavy rainfall primarily because of the increase in the population density and the urbanization, or what you call land use, land cover change. And this is the cause of worry. And so therefore we need to have urban climate treated differently than the rest of the subject. In fact, GST has recently launched a national network program on urban climate, and I think we are taken 3 cities, one coastal city, Bhubaneswar, one inland city, Bangalore, and one Himalayan, South Himalayan place like Dehradun, and we are trying to study as to what impact these climate factors and infrastructure changes are making to the urban climate. So very important topic. All that heavy rainfall that is happening in cities like Mumbai or Chennai or Delhi that needs a thorough study as to why it is happening more in the densely populated cities. That's it I want to say. Thank you.
Thank you, Dr. Gupta. I mean, there are many questions on YouTube right now talking about many things related to agriculture, related to health, but we don't have time. But I don't want to dishearten our audience. We have a dedicated forum in the Science Policy Forum platform. We would definitely like to engage with you. Please engage in those discussions on that platform, on that website, and we'll carry forward these questions. All these questions would be sent to the STIP2020 Secretariat for further deliberations and discussions with the experts. So we will be coming back with all the answers in form of our policy. I'm pretty sure of that. Before ending, I would like to have a quick round and to just ask all our panelists. So I would request each of our panelists to say, what is your vision for weather and climate research services for 2040? Because I don't see that it ends at 2030 or 2020. We have to have a much more long-term vision for that. So this is like a one-liner because I'm asking about your vision. What is your vision for weather and climate research and services for 2040? And I would begin with Mr. Kurian, because he has been sitting for quite a long time. Now I would ask him to jump in and give his remarks on that. Over to you, Mr. Kurian.
Thank you. Am I audible? Hello? Okay. Yeah, I just wanted to say that the IMD has the backbone of the infrastructure. It should stay, and IMD should focus on its core competence of weather and climate information services, and leave gradually the job of dissemination to these weather apps and other connected devices and all sorts of things. So just concentrate on the core competency and digitally transform over the next decade or so. Thank you.
Thank you, Mr. Kurian, for raising the point of focusing on core competence of the department. And for that, I'll move to Dr. Mohapatra for his vision on weather and climate research services for 2040. Over to you.
I'll summarize like this. We will be passing through a transformation, moving from the analog digital process to completely digital process of monitoring and forecasting by 2030. The role of meteorologist will change from a conventional meteorologist to a smart meteorologist. Instead of providing forecast, they will be interpreting the forecast and facilitating the various stakeholders for its better utilization for socioeconomic applications. And third one is that the major focus or thrust will shift from what the weather will be to what the weather will do. That is from simple weather forecast to impact-based weather forecast and risk-based warning services for all the sectors. Thank you.
Thank you, Dr. Mohapatra. And now to Dr. Sharma for her vision for weather and climate research services for 2040. Over to you, Dr. Sharma.
Yeah, I would like to say that India is a signatory to most of the global climate action conventions. And I definitely see India as a leading country by 2040. And in all the sectors, be it R&D, be it technology transmission, and be it the preparedness and the adaptation and mitigation strategies. Also, I see that each smallholder farmers are well equipped with the latest technologies and do the farming with the precision. So I finally would like to say that it will be a real climate smart agriculture by 2040. Thank you.
Thank you, Dr. Sharma. I would like to know from Dr. Gupta as to what is his vision for weather and climate research and services for 2040.
I think I would say that I always follow the slogan that I would like every citizen of this country to go weather-wise and not otherwise. And they should, consult weather first, then do anything else. Thank you.
On this platform, and thank you for that. And with that, I'll move to Professor Barua. What is her vision for weather and climate research and services for 2040?
Right, coming from an academic institution, I think my vision is that it is in every academic institution as a core subject, which is not been done at the moment. And it is also important for everybody to understand that climate change is a larger subject under which every other discussion that we are having, whether it's water, poverty, etc., everything will come into it. So I will go with what Dr. Gupta mentioned. Everybody should think like weather-wise and not otherwise.
Thank you, Professor Barua. And I think Professor Gupta's mantra is already rolling up. And so on that note, I move to another academic and policy practitioner, Professor Dash, to give his vision for weather and climate research and services for 2040. Over to you, Professor Dash.
Yeah, I have for research, I have the vision of having one community art system model where all the young interested scientists will get a chance to develop in the core. And from service point of view, my vision that PPA mode of action, responsibility so that it will benefit the society. So India-centric community art system model and PPA mode of climate service.
Thank you, Professor Dash, for bringing this. And I think this is how we conclude in terms of bringing in coordination, collaboration, and coherence across weather and climate research and services in India. And on that note, since the time has already gone beyond, but we still see audiences, that means that we are keeping them intact on the platform right now. I would invite Dr. Gupta to give his remarks and the vote of thanks. Over to you, Dr. Gupta.
Thank you, Nimita. In fact, it was truly a pleasure to have all of you. And I would say that this is the first of its kind discussion in the country where the varied expert and I would say the most authoritative today have joined on an open webinar which is live streamed across the country, and not just across the country. I'm told that it is being live and being watched by several people from across the world. So I think we need more and more such webinars to come. It's very important. This is a very important topic, weather and climate. It touches everybody's life. I think it's very important that we discuss, debate, and have open-ended discussion where the scientific ideas and vision are shared with the people. I think this is another thing that we need to do. That we need to communicate ourselves to the people. Reach out to people and make them learn what we are doing. And I am very glad that today Dr. M.Mohapatra brought, a kind of a clear message to people that what IND is doing. I think we need to have more such things. Thank you all. I think I really thank everybody from bottom of my heart, from on behalf of the team STIP, and also on behalf of the Office of BSA and the Department of Science and Technology. It has been wonderful interaction, and I'm thankful to all the people or the viewers who have joined. This is the largest ever what you call response that we got from everybody. All my team here, I'm grateful to Shagun, Amrita, and all the team of Science Policy Forum, and to most importantly my co-host Nimita, who, as usual, being always she rocks every time. So thank you very much. It's been pleasure. So over to Nimita for your final words. Thank you.
Thank you, Dr. Gupta. And I must say the amount of outreach we have for this panel is commendable. It's startling, and I would say that, as you rightly said, we need to have more such focused debates and discussions, and we look forward to make more such platforms to have such discussions. On that note, I thank all our panelists for giving their time to come and engage with us to have discussions. As rightly said by Dr. Gupta, that this was a fruitful panel, and it was, all the deliberations were extremely enriching. On that note, I would say that I would like to thank the audience on YouTube and on different social media for being with us, for sending your questions. Thank you so much. And a big shout to all my teammates at SPF, at Gooby Labs, and the STIP2020 Secretariat. With that note, we bid you goodbye. Have a good evening. Thank you so much. Bye-bye all.
Yeah, the panelists may stay for a minute for that.
Are we done with the live? Over?
I hope so. Lakshmi, the